Hello, YouTubers, and welcome to the inaugural episode of Chris Creates a Thing. Today, I'm going to create a sheet metal bracket that attaches a part to a frame element. But before I get started with that, I owe you guys a bit of an introduction. I'm Chris. I'm a mechanical design engineer who has been working with SolidWorks since 2008. I'm recording this in May of 2023, so that's somewhere around like 14 to 15 years of using SolidWorks. Needless to say, I love working with SolidWorks as an application, but as a CAD administrator, I understand that it can sometimes be very confusing for people, especially starting out, to figure out how to work through different modeling scenarios in SolidWorks. So I'm starting this video series to show you guys how I approach those scenarios to create useful and elegant designs in a simple way. I know a lot of videos now are using newer versions of SolidWorks, but I realize that many people may be using earlier versions. I will personally be using SolidWorks 2020. I'll also admit that my interface, and in particular the shortcuts that I use for different commands, may be a little bit different from what you may be used to, and maybe a little bit different from what you get out of the box right when you install SolidWorks. That said, I'll try to explain what I'm doing in as much detail as possible. I'm also using the Windows Power Tools utility to show crosshairs around my cursor. The intent there is just to help you guys see where I am pointing and clicking. And if there's anything that you find confusing or perhaps unorthodox about how I'm going about doing things, by all means, question it and feel free to mention it in the comments. So, moving along, for this first video, I'm going to set up a common fixturing problem and then work through how to solve it. Again, we're going to create a sheet metal bracket that attaches a part to a frame. I worked through this scenario previously in the electroplating industry. I worked for a company that had to produce essentially copper bus bar racks that would get immersed in electroplating solution for the purpose of essentially chrome plating racks, or rather chrome plating automotive trim body components that you would see on your vehicles that are on the road. So let's get started. I'm going to go ahead and start a new assembly. And it's prompting me for an existing part. I'm just going to leave that blank. I'm going to save that assembly to my project directory. I'm going to go to that here. Give it a name. I'm going to call it something like compound angle bracket assembly. And then click enter to save it. Now I'm going to create a new part. And I'm going to go to the front plane. I right-clicked it, selected sketch. I'm creating a centered rectangle. This is going to be the frame element that we're going to be attaching to. It's 3/4 inch wide by 24 inches tall. And we'll OK that dimension and we'll confirm the sketch. And we will transform that sketch into a base flange from the sheet metal tab with a thickness of 1/4 inch. And that creates this base flange 1 body. I just changed the material to copper. And I'm going to save this. We'll call it vertical bus bar. And then save. Okay. We're going to return back to the assembly. We're going to insert that vertical bus bar. We'll click the green check. That will position it at the origin point and fix it in position. Okay. And I'm going to go to McMaster here. I got to find the part that I want to attach. So I love McMaster-Carr. It's a great place to find 3D models of various mechanical engineering parts. Right now, and by the way, I'm narrating over pre-recorded video, I am searching through here to find a particular clamp. So bear with me on this. Sometimes you can just go ahead and search and you'll find what you need. I'm specifically looking for a type of clamp. It's a loop clamp. So I'm scrolling through here to find that. And believe it or not, this is, many hours of what you typically deal with as a mechanical engineer, is searching on websites like McMaster-Carr to find what you need. So, all right, I found the loop clamp. And I'm going to specify a 1/4 inch ID for that. And I'm going to pick the first listing over here. So I'll click that link. Okay, that expands the box. I'm going to go to product detail. When you go to this section of McMaster's interface, there's a lot of extra information listed there. I like to look there for things like, ROHS, reach, compliance, those sorts of things. So, but I've gone ahead and downloaded that part. I'm going to do a little bit of setup here within the part just to make it a little bit better for use later on. I'm going to set up the background to a plain white. I'm also going to toggle down the image quality settings. So McMaster-Carr parts tend to come in at a very high resolution. If you have a lot of these parts in an assembly, it can actually create performance issues. So I adjusted the image quality, saved the part as a new version under the 2020 copy of SolidWorks. I'm going to go back to the assembly and place that part in the viewing window. I'm going to go to Insert Components for that and select that Open Document and roughly position it in space. This is not going to be the final position or orientation for that matter, but nonetheless this approximately gets it where we want it to be. I'm going to right-click drag to reorient this part, and I'm just kind of eyeballing it. This isn't a precise orientation that I'm doing here, but really just for the purpose of illustrating that this part is oriented at a compound angle. It's not at an angle to any one of the primary planes that you have in SolidWorks. It's not at an angle to the front, the top, or the right just by itself. It's actually at an angle with respect to multiple of those planes. Hence, it's a compound angle. Very difficult scenario for positioning and attachment. So I'm using the right-click Move with Triad option here to move the part around in space, changing my views so that I can see a little bit more clearly where to position the part. I'm going to adjust the location of it, looking at it from the top, seeing where it is in relation to that frame element, and positioning it where I want it, looking at it from the bottom, and then I'm going to switch back to the front view, just moving it around, trying to get it into a spot that I think I might ultimately want that part to be in. Okay, now I'm going to save my assembly, rebuild and save. And I was thinking about inserting a part, but I realized what I want to do is actually create a brand new part in the context of this assembly. So I use that Insert New Part function for that. And it's asking me to pick a plane or a surface. I'm picking the front of that frame element, which will become the front plane of this new part 2 that just popped up in the feature tree. But I'm not going to actually sketch in that plane. Instead, while I'm still editing this part, which has no features yet, I'm going to do something a little bit different here. I'm going to actually create some reference geometry. So I'm going to go to Features tab, Reference Geometry, and then I'm going to go down to Axis. So what I'm going to do here is create an axis, reference axis, between that loop clamp and the front surface of that frame element. Okay, notice where it positioned it. Okay, it's way out there in space. It may seem a little strange what I'm doing with this, but that's going to be a very critical step in setting up a sketch plane. So what I'm trying to do next is actually identify a point location reference on the loop clamp. So I'm going to sketch on the loop clamp, and then after I've created that line between midpoints on that slot, what I'm going to do is I'm going to put a point on the middle of it. Exit out of the sketch. I'm fixing the position of the part because I don't want it to move around in space, specifically the loop clamp. Now I'm going to create a reference plane. I'm going to go back to that axis that we previously created. That's the first part, that first reference. And then I'm going to pick that point. I'm going to change the first reference. Instead of being a coincident relation, I'm going to change it to be to create a plane that is actually perpendicular to that axis. So this plane will be useful. We're going to use it to actually sketch the bracket. So makes it very easy to connect it to that frame element. So we'll click OK. That creates our plane. Next thing to do here is going to be to create the sketch. So we're going to start that. And we're going to start drawing some lines. And we're just kind of drawing in free space here. We're not being precise about it, because what we're going to do is we're going to view this plane normal to, and then we're going to start creating some relations between the clamp, or rather between that frame element and the lines that we just created, and also with respect to the clamp. So I'm making a collinear relation there between that line. I also did the same up there at the top of the profile. And I'm adding a perpendicular relationship to that line that connects between the clamp and the leg that's attached to that front face of the frame. I'm doing a little bit of dimensioning here. And this is just kind of rough. I'm just entering in a rough value here, ballparking it. So I'm using the Smart Dimension tool for that. And on my interface, I have that mapped to the D key as a shortcut. Very handy. I just dimensioned that origin point, which was positioned at the center of that hole. Made it half of that 1 inch, just to center it. Okay, I'm creating a base flange here, and I'm giving it a mid-plane relation. And I realized as I was entering in the value, I was thinking that was the box for the thickness. So that actually needs to be 0.75 for the the width of that bracket. Now I enter in the thickness, and the last value that I'm going to enter in is an appropriate radius for the bends. So I'll put in 0.07 for that and click OK. Now we just created the bracket, but notice that it's not actually connected to the frame. Okay, so I have to go back and troubleshoot this a little bit. So I'm going to go back to my sketch. I'm going to edit it. And keeping the view at an angle, and rather than orthogonal, which is what confused me here. I'm going to start redefining the relations on the legs of this bracket. So I'm taking out that perpendicular relation. I'm taking out the collinear relation. What I just did there was I created a pierce relation between that endpoint and the edge of that frame. And I'm increasing that leg to 1 inch. Okay, so at this point I think we're in good shape as far as overall dimensions. I'm just kind of inspecting it, moving the view around the part to see what everything will look like. Okay, so now we have actual sheet metal geometry that can be used for attachment. But the next thing we need to do is add holes for fasteners. So I'm going to edit this part in the assembly. I'm going to edit the bracket. Right click, edit part. And I'm thinking about how I want to get this hole centered on both the midplanes of the frame element and the bracket itself. So I'm sketching out some geometry here to try to figure out where that center point should be on both parts. Now, I'm doing this as a sketch, and I realized that what I actually wanted to do was do this sketch in the context of a Hole Wizard feature. So I'm going to go up to Hole Wizard under the Features tab. And sometimes people have favorites here. At my workplace, I have favorites set up, but I'm going to create a screw clearance hole. It's going to be for a 1/4-20 type bolt, and it's got a loose condition on it. I'm going to go to that Positions tab, put a point there to specify where that hole is going to be. And now I'm going back and doing what I just did before, which is create some geometry for centering that hole on both the frame and the bracket. So I just added a perpendicular relation there to the midpoint. Okay, so I just did that on the bracket, but now I also need to do it on the frame element. And this is a pretty simple step. So I'm going to again create another quarter hole on this. And I just control selected the point and that edge, that circular edge, and applied a concentric relation, so that that hole is centered at all times. Even if this part moves around, it's centered on that existing hole on the bracket. So that's creating an in-context relation. You see those double arrows next to the 1/4 clearance hole feature. That represents an in-context relation. So now I'm doing the same thing here. I'm creating a hole for attaching the clamp to that bracket. And this again is pretty easy. I have that sketch there. I can just make a coincident relation between those 2 points. And click OK. And that finishes the feature. So this is a pretty easy way to create brackets for parts that are at an irregular orientation. In reality, you'd probably want 2 holes on the frame, and you'd probably want that bracket to be shaped a little bit differently. But 2 holes would help to prevent that bracket from rotating. So I am now saving that part externally because it only existed in the assembly. But now it actually exists in a separate file, in a part file. And I want to show you something interesting about this. So, question is, what would happen if we change the orientation of that clamp or positioning of it? But in order to test that, I had to set that clamp to a floated position instead of a fixed. So I'm right-click dragging and kind of moving it around to test the change in bracket geometry. And notice how it updated. Okay, it was pretty clean that time around. I'm testing it a bit some more, and I'm getting some weird results here. Note that that hole is now passing through multiple planes. So if I go back to that particular hole, that was the second one that I created, I realized that my end condition was set to through all. So I can set that to up to next instead, and that will force it to only go through one thickness. But I'm also noticing that the plane is a little bit off from where it should be. So this isn't going to be perfect in every case in as far as orienting the part in every single possible orientation. The intent will change and you'll start to get weird little issues like this. But if you're starting out from scratch and you're not making major changes to positioning, this can actually be a pretty useful tool. So again, kind of testing that orientation, getting some weird results because I flipped normals. So you can't make a lot of extreme changes in orientation because that's going to change the position of that axis that we created earlier in the tree. So here it kind of makes sense. It's back to the way we would expect.